Today we'll be discussing exceptions handling in Java, and we'll look at the Java exception classes and the different types of exceptions we have, and some of the Java exceptions keywords that should be used when integrating exceptions into your application. And we'll also look at the default exception handling, so how Java handles exceptions, and some points to note when handling exceptions. So first of all, exception is an abnormal condition in your system, something that disrupts the normal flow of the program, and it is an object that is thrown at runtime. And exception handling in Java is a very powerful tool that is useful for handling runtime errors. So your normal flow of your application can be maintained, so your application doesn't just stop or just shuts down. Exception handling helps to handle something that goes wrong in your application, and the application still continues to flow. An example is the IO exception, which is the input output exception, class not found exceptions. There's the null pointer exception. There are different kinds of exceptions in Java. So the kind of error or problem you think your application will throw will determine the kind of exception you will try to catch or use in your application. The main advantage of exception handling is to maintain the normal flow of application. So like I said earlier, we don't want our application to just stop when maybe a user is using it and it just stops and the user has no idea what's happened, but in the back end, the application has stopped working and ran into errors that exceptions could have handled. So we've got three types of exceptions: the checked exceptions, the unchecked exceptions, and the error. And we'll look at this in just a few minutes. So an example is if I've got 9 statements in my application and a problem occurs in statement 5, if I do not use any exceptions, my application will just stop at statement 5 and not work. So it will just shut down. And statement 6, 7, 8, 9 would not run. But if I've got exceptions handled in this statement 5, my application will run and we execute as required. It would throw this exception and continue with the other statements in the application until everything in the application that was meant to be executed is executed. So this is one advantage of exceptions. And this is the hierarchy of the Java exception classes. We've got the objects, which I've been saying in the class is the parent class of all objects in Java. So the default Java object class is the parent class of the throwable class. So the throwable class is the root of the Java exceptions hierarchy. And the first branch is exception and the second branch is error. So exceptions class is used for exceptional conditions that your program should catch. An example is the null pointer exception, the IO, the compile time exception, etc. While the other branch error is used by the Java runtime system to indicate errors having to do with runtime environments. So this one are things that you might not be able to catch. For example, if your application is out of memory, or virtual machine error, or assertion error, or stack overflow error. So these are the two main branches in Java exception hierarchy. And the three types of exceptions. For the exception branch, we've got the checked and unchecked, and on the other side, we've got error. The checked exception, these are classes that directly inherit the throwable class, except the runtime exception. So checked exceptions are checked at compile time. Compile time, I explained this in a few classes earlier, is the time it takes for your application to be compiled by the Java compiler, and runtime is when your application is actually being run. So errors checked at the two different times are different. So there are errors checked at compile time and there are exceptions checked at runtime. And checked exceptions are the ones that are checked at compile time. So when your application compiles your programs and just checks that everything is in place for it to run. And for the unchecked exceptions, these are classes that inherit the runtime exception. For example, we've got the arithmetic exceptions, the null pointer exceptions, the array index out of bounds exceptions, the number formats, etc. And they are not checked at runtime because they're not checked at compile time rather because they're checked at runtime. So this subclasses belongs to this runtime exception. And examples of checked exceptions are IO exception, SQL exception, class not found, etc. And this directly inherits the throwable class, which is exception. So an exception inherits the throwable class. And error indicates that there's a serious problem that we should not try to catch because it is irrecoverable. It might have to do with getting more memory or fixing something that has happened in your application. So we've got out of memory error, the virtual machine error, and the assertion error. So whenever an exception happens in a method or in a class, there are certain steps that the Java compiler goes through. This is all done in the backend, so we don't actually see it. And then there are some results that the Java compiler displays on our screen. So in a method, if an exception occurs, the method creates an object known as an exception object. Then the method hands this off to the runtime system, which is the Java virtual machine. And the exception object ideally contains the name and description of the exception and the current state of the program where the exception has occurred. So if I was dividing 10 divided by 0, and we all know 10 divided by 0 is impossible, this will throw an exception, and the JVM the method will first create an exception object, maybe like number out of index exception, and then you'll create that object and hand it off to the runtime system, the JVM. And this exception object will contain name and description of the exception. So maybe my object name is number out of index 1, and the description, the Java would already know that, oh, this is an object of number out of index exception. And I was trying to divide 10 by 0, which led to the exception. So creating the exception object and handling it to the runtime system is called throwing an exception. So all this process that we've listed here occurs when an exception is thrown. And there might be the list of methods that had been called to get the method where the exception has occurred. So this occurs when you have methods inside methods inside methods. So what Java does is it gets the list of all, basically gets the history of where that exception has occurred. So if I had a method called divide, and the divide was in another method called arithmetic, and arithmetic was in another method called math, the exception object will print out each of these history locations, and the ordered list of method is called a call stack. So if you can see this diagram here, I've got a method where an exception has occurred, so divide by 0, and it throws an exception. So it is looking for the appropriate handler, so where the exception handling takes place. And this is another method without exception handler, or was in divide by zero, and it would still be looking for the appropriate handler. So this one has the exception handle, which means handle exception, and it catches the exceptions thrown by the divide by zero method. So this calls that method and calls that method, and that makes up the call stack. And this is very useful in finding out where where the problem is in your application, so you can know how to go about fixing it. Because call stack gives an ordered list of method of where your exception or your problem is. So the JVM searches the call stack to find the method that contains the block of code that can handle the occurred exception. And this block of code is called the exception handler, which is this method here. The runtime system starts searching from the method in which the exception occurred and proceeds through a call stack in the reverse order in which the method was called. So it was going like this, and the call stack will go from here to here to here to here. And if it finds the appropriate handler, it passes the occurred exception to it. Appropriate handler means the type of exception object thrown matches the type of exception object can handle. So in this method, if I put, for example, an IO exception, it is not going to catch my divide by zero because it is not a number out of format exception. So we need to declare the appropriate exception for divide by zero to catch. So the exception that will be caught here is, the exception that was thrown here is a number out of index exception, and the exception that should catch, the method that should catch it should have a number out of from index exception. So the method throwing the exception should match the method catching the exception. The exceptions defined in those methods should match. And if the runtime system searches all the methods on the call stack and couldn't find the appropriate handler, then the runtime system hands over the exception object to the default exception handler, which is part of the runtime system. This handler prints the exception information in a format and terminates the program abnormally. So if the JVM cannot find the correct exception, it would have no choice but to terminate the program and print out just the default exception object, which is this one, and will terminate the program abnormally. So we've got 5 exception keywords that helps with exception handling. We've got the try, catch, finally, throw, and throws. And these 5 are used differently. Try and catch are used together. The try keyword is used to specify a block where exception code is placed, and it must be followed by either catch or finally. So in a try keyword, you put in your code as usual, and just wherever you want to do, like you want to add 2 numbers together, we would use the try keyword we would write our code in the try keyword. And the catch block is used to handle the exception. It should be preceded by the try block. So you should first use try and then use catch. So try and catch are like twins. They should be used together. Try is the first twin and catch is the second twin. And it can be followed by the finally block later. So we'll look at an example of try and catch now. And I will just open my IntelliJ. In my IntelliJ, I created a class called exceptions test, and it has a main method. So we'll write our try and catch in the main method. So to write try, you just put try, and I get an error because it should be preceded by a catch clause. So you cannot just use try on its own, you need to add a catch clause to it. So I just put catch. And if I don't know what exception, we'll first write the code. So I've got an array of numbers 2, 4, 6, 5, 8. And if I just print out numbers, the index number 10, this is going to obviously throw an error. If we do not have the try and catch, it will probably just, let's try without the try and catch first. So we've got these two statements. We've got these two statements, and if we try to print it out, it should run into error because, and stop our application, because this array only has a size of 4. So an index of 10 should not be found. If I try to run this, I get an exception automatically by Java. But if I write my exceptions, my program would have not finished. It would continue as required. And as you can see here, it's asking us to throw an array index out of bounds exception. So this is also helpful when you don't know what exceptions you want to throw. And Java has already said, oh, this should have thrown an array index out of bound exception. So I'm going to put my try and catch clause. I've got my try and I want it to catch. You can just first allow it to catch just an exception. So exception is the parent of all the other subclasses, of all the other sub exceptions that are unique to each problem. And just say something like print out something can just say wrong or something. And just for you to know that the application continues, we'll just print out application ends. You can see that my application actually ran through, got into an error, and found where the exception is placed, then printed out what was meant to be the outputs, and then also finished that and ran the last statement in the application. So my application got into a problem or solved the problem and did not stop the application abruptly. So try and catch helps to write your code. You can write your code in the try clause and then in the try block, and then you catch any error or exceptions in your catch block. So since we know that it is an array out of bound exception, array index out of bound exception, just put exception. You can just say something like problem is so it just says that your problem is an array index out of bound exception. So the index you are looking for does not exist because your array only has a size of 4. So your last index should in fact be 3. So this is just an example of using try and catch in Java. And the finally keyword is used to execute the important code of your program. So it is executed whether an exception is handled or not. So after you've put in you've put in your code in your try block, and then you've caught the exception, the finally can be used after the exception has been handled. If the exception was not handled, the finally still runs and executes something, whatever you've put in the program. So we'll do an example of that now. And then we'll just add finally, and I'll just put this inside. Try catch is finished and the application ends. So you can see our try and catch was done and then the application ends. If there was no problem and I just print out 1, so I'm printing out the second index of my number array, which should be 4. Even if there was no exception caught or thrown, the finally will still run. So if I run this, my application printed out the second index, which is 4, and then since there was no exception, the catch block was ignored, and then it went on to finally and printed out my try catch is finished and my application ends. So finally can be used to put in code that you want to execute after an exception has been carried out, or you don't want it to be in your try block, so you want it to run anyway regardless of the exception. The other keyword is throw, and is used to explicitly throw an exception. You can use this in a method or in a class. And you can throw either a checked exception or an unchecked exception by using the throw keyword. So for example, we just say throw exception, throw new IO exception. So we'll write a new method in our class called public static void check. If I want to check the age of somebody, so put in a parameter which we need, which is the age, and then if age is less than 21, we'll use the throw keyword to throw an exception. So throw new exception not valid to young. Say else past check. We'll just choose the arithmetic since we know what exception we're throwing. It's regarding arithmetic, so we'll throw the arithmetic exception. We can't throw a new exception just like that without declaring it in the method using throws. So we're going to use the new arithmetic exception because we know that we're dealing with numbers and arithmetic. So I've got my if-else statement here. If the person's age is less than 21, the system throws an exception saying not valid, too young, or else the system prints out past check. And we'll just use it in our application here. So just say check age, and I'm going to put 16. So it should throw a new arithmetic exception and give me this not valid, too young. So if I run it, I see that it throws an exception saying not valid, too young, and this is the call stack. So when the application is running, the application runs from the main method and goes through all these things. And then when it gets to check age, it goes into check age and sees that, oh, there's a problem. Age is less than 21, so an exception has to be thrown. So it throws that exception and a call stack was created. Our call stack is quite small because we're not dealing with many classes or many methods being nested in other methods. So I can see that it started from my main, and then the problem or the exception was in my check age. So if I click on this, it takes me to this line. And if I click on this, it takes me to this line. So this helps in certain IDEs to find out where the exception was actually made or where the problem started from. So from here, my problem started from here, which ended up here. And I just want to put something underneath this to show that my application doesn't still stop. So I'm just going to print out this application ends. Okay, so I think the application ends not print because the problem because we're using the throw new keyword. So if I had used a try and catch, the application would still continue. Or throw is also useful for scenarios like this. I also need to do more research and check out why this application ends not work. So I'll get back to you guys on that. So the last keyword we use it is the throws keyword, and it is used to declare exceptions. It doesn't throw an exception, it just specifies that an exception may occur in that method, and is always used with method signature. So I was doing that example here when my application wanted me to throw exception. So it just indicates that an exception will be thrown, or you can say arithmetic exception. So it just indicates that an arithmetic exception will be thrown. It doesn't necessarily have to throw an exception, it just indicates that, oh, something might happen. So an example of that We'll create another method for that for clarity. Let's say X throws. We'll just say throws input output exception. And input output exception is imported automatically because we need that class. This is throw new input output exception when device error. And then we'll have another class called which will throw another IO exception, but our method X throws will be called in next throws. So we'll just call method. I'm going to name it A and B. And then we'll have another method, public void C throws, and this one would have a try and catch. So try, we'll call the B throws inside, and then catch. I'm going to make it catch an exception and print out so we've got three methods here. A throws, with throws, and IO exception. So this deals with input and output. And it throws a new input output exception of device error. And this B throws also throws the IO exception because without this keyword, we will not be able to execute our A throws. So we can't execute it because A throws deals with IO exceptions. So the method that deals with IO exceptions and is being used in another method, the second method automatically have to throw an IO exception. And we've got a third method called C throws, which calls B throws and catches the exceptions for us. So we'll just create a new object in our main class. And I will comment that one out and create a new exception test. Exception test as my object and calls new exception test. And I'll call C throws from here. So C throw will automatically call B throws, which will automatically call A throws. And exception test dots. And then I'll also print out my application ends. So if I run this, you see that it calls exception is handled, and then application ends. If I use a new one, if I use the arithmetic expression and throw in a new arithmetic expression, so and then if A equals to 5, I say A is less than B, print out. Okay, I'll say if in C equals 5 divided by 10, and if I say if C is, actually I'm just going to do the 10 divided by 0. So yeah, I just copied and pasted my check age into this new method called aThrows, which takes in a parameter of age and throws an arithmetic exception. And if age is less than 21, throw a new arithmetic exception, not valid too young, else system pass check. And I'll delete this one. And my B throws, I am manually imputing the age, and this should throw an arithmetic exception, because this is throwing an arithmetic exception. And my C throws just calls my method and then catches it if anything's wrong. So it basically says exception is handled and application ends. So throws is useful if you want to declare that there's something in your method that would need an exception. And some points to note when handling exceptions. In a method, there can be more than one statement that might throw exceptions. So put all these statements within its own try block and provide separate exception handler within catch blocks for each of them. So just create try blocks and then corresponding catch block for the statement that you think might throw an exception. If an exception occurs within a try block, that exception is handled by the exception handler associated with it. So to associate exception handler, put the catch block after it. There can be more than one exception handler. So each catch block is an exception handler that handles the exception of the type indicated by its arguments. What that simply means is this catch exception that we declared in this statement this argument deals with arrays. So because it's an array index out of band exception, it's an object of array index out of band exception. So it only deals with exceptions regarding arrays. So we can rename this if we want small clarity. We can just rename it to array exception. And then if you have another problem regarding another exception that you might have. So if I say int a equals 10 divided by 0, and I can catch an arithmetic exception. So this is arith exception. And I print out problem is so I can also have one try block and then multiple catch statements, catch blocks to catch different exceptions that might occur in my try block. So if I try to run this, hopefully it will print out two exceptions that I declared in that. So in my application, I've got two exceptions that was caught. The first one is the array out of bound exception, which you could not see because this was a correct statement. If I change the index of my array to print out the 11th index, the 11th number of my array, I would get an array index out of bound exception. One try block can only catch one exception at a time. Sorry, I forgot about that. So when it goes here, it disregards everything else here and then just goes to catch. So it's best to put different arrays in different exceptions in different try blocks because only one exception can be caught at a time in a try block. So I'm going to put another try here. Okay, another try here and then catch my exception. So we've got two try blocks. One try block as catches an exception regarding array index out of bound, and the other catches an exception regarding arithmetic. So if we run that, we should see the two exceptions that was thrown and catch. So the first problem is array index out of bound exception, and it's just basically saying that there's no index of 10. And the second problem is arithmetic exception, which basically says you can't divide a number by 0. So if you have different statement or different code that needs exceptions, it's best to put them separately in corresponding try and catch blocks to help handle your exceptions. And like as I was saying, each catch block has an object parameter of the exception. So this is arithmetic exception, which takes in the parameter of an arithmetic exception object. And this array index out of bound takes in a parameter of array index out of bound objects. So each catch block is an exception handler that handles the exception of the type indicated in its arguments. So if I put in arithmetic exception and I'm trying to catch null pointer, it doesn't work because I have not put in the proper catch for it. The proper exceptions that should be caught for it. And for each try block, there can be 0 or more catch blocks, but only one finally block. We created different catch blocks, but like I said earlier, if you have only one, if you have multiple exceptions in your code, only one catch block will be called. So even if you put multiple catch, if you don't know which, it's good if you have multiple catch blocks if you don't know which exceptions can be caught, because only one exception can be caught in a try block anyway. So if you don't know, if you have no idea which exception will be caught, you can just put as many catch block as possible. But if you know what exceptions will be caught, then, or if you know what exceptions will be caught, then just put the catch block there. Just one catch block, because only one exception that is thrown will be caught. Because the compiler starts from here and then just ends on where the exception happened. It doesn't go back. That's why it's best to put whatever you want to put that doesn't have an exception in finally. The finally block is optional. It always gets executed whether an exception occurred in a try block or not. If an exception occurs, then it will be executed after the try and catch block. And if an exception does not occur, then it will be executed after the try block. So the finally block in Java is used to put important code such as cleanup code, like closing the file or closing the connection if you are dealing with databases or if you're dealing with file handling in your application. So this is an example. I've got an integer of a, which is 10 divided by 0, and it throws an exception object. Is it handled? Yes, the rest of the program will be executed. Is it handled? If it's not handled, it prints out the exception description. That is what type of exception occurs, and prints stack trace, and then terminates the running program. So this is just an example of how exception works. One thing I wanted to say is the difference between throw and throws, the two Java exception keywords. Throw is used to explicitly throw an exception, and the throws is used to declare an exception. So if you know that an exception will definitely occur, you can explicitly define that exception anywhere in your code. But if you know your method might throw an exception, you can use throws in your method signature. Throws is followed by an instance throw, so it is in this place is followed by an instance of an exception. So throw new arithmetic expression. So we're creating a new arithmetic expression object and using throw. So that's what throw is used for. And throws is followed by a class. So this throws is followed by arithmetic expression. throw is used within a method, while throws is used in a method signature. And you cannot throw multiple exceptions, so you cannot do this and throw null pointer. It won't work, it will throw an error. But using throws, you can declare multiple exceptions, like the null pointer exceptions, array out of index, etc. So these are the main differences between throw and throws in Java. So that's the basic explanation of what exception entails in Java. And if you want to read more about exceptions, because it's a very wild topic, you can go to resources like Gigs for Gigs, W3 Schools, Tutorial Point, Java T Point, even the Java Oracle docs itself, and you can get more explanation on exceptions and exception handling in Java and the different types of exceptions we have in Java. It's like the IO, the SQL, and how to use them. But this is just the basic explanation of what exception entails in Java. Does anyone have any questions? Just thank you all for joining this class this past 6 weeks or 7 weeks. And if you've got any other questions, you can just send me or only a text message on Telegram, and we'll get back to you regarding any questions you might have. So thank you guys, and good luck.